Hello. So today we will be solving this problem distinct subsequences. Okay. Uh, we have this problem in 2D dynamic programming part. So we will be solving this particular problem. So the problem says given two strings s and t, return the number of distinct subsequences of s which equals t. The test cases are generated so that the answer will fit in a 32-bit signed integer. So we have to find s and t. We have two strings. Number of distinct subsequences of s which equals t. Okay. So here we have three sequences. Okay. First we can take these two b's. Okay. Then we can take last two b's, then we can ignore this middle b, that way we can form the rabbit. Okay. Okay, here we have 5 as the answer. Means we need to find subsequence bag in this string s. Okay, so these are the 5 ways to find the bag. uh, this first ba and this g, then this last g, then this b, this a, this g. Okay, this b, this a, this g, this b, this a, this g. Okay, so basically we need to follow skip and take dp. Means suppose we are at ith index in this particular in t string. If we are at this index, we will check if this index matches to this position. So if this matches, then we can uh, take this consider this b, or we cannot consider this b. Means we have two options. And suppose we compare if this b with this a, so here we don't have any other option, we have to skip it because it is not matching. Okay. So I think first we should write the brute force solution using skip and take part recursively, and then we can see how we can memorize it. Okay, so let's call a function passing string s and t, and initially we are at 0th index in string t. This is string t and we are at so basically this is the index in t. Means we are starting from this index, we are comparing it with the s. Okay, we also need a index in s also, that in which position we are at s. Okay, so let's say we are at initially we are at 0th position in s. So let's call this I and let's call this j. So I is index in s and j is the index in t, or we can write as index s index t. Okay, so we need to write the base condition. So base conditions will be like if our index in the t strings reaches the t dot length, that means we have traversed the whole t string. That means we have found the whole subsequence in the s part, so we can return one that we have found a subsequence. And other condition will be if our index in the s becomes, means if we transfer the whole s substring s string, that means we have transversed the whole s string, and this condition is not satisfying. If this is satisfied, then it should be handled here itself, but uh, this condition is not satisfied, so we reach here and we check. We have fully transversed the s string and we haven't found the subsequence t, so we can return 0, that we haven't found the t substring in the s. Okay, so now we have first option is skip. We can skip the current, what we can say, current character. So how we can skip the current character means, suppose we are at let's take this example. Okay, suppose we are at p, and in this we are at 0th index, and in this s string also we are at a 0th index. So we see we have a first option that we can skip it and we can move our s pointer to a pointer. Okay, so we will increment our s pointer by 1 and we'll keep the t pointer at the same position. Then we have a take condition, but in order to take the current character in the string s, it should be matching with the current character in the t. Then only we can take the current character in the s. Wait a second. Okay, so if s dot character at index s is equals to index t dot, wait a second, t dot character at index t. Okay, then we can take it. So int take. So taking means we are calling this function and we have taken the current character because it matched, and we can move to next character into both strings, because now we have matched the b character. Now we will be going forward to match the a character. Okay, and we will take our result as the maximum of these two results. Means sorry, not maximum, we should be adding these results, because we need to find all the subsequences, means after skipping and after taking. So then we need to add this to the skip part. Okay, and at the end we can return the skip. Means at this point skip will be storing both from skip part and take part, means both the ways to get the t as the subsequence of s. Okay, so let's see if this brute force solution is working. Okay, so it's working. So I think we need to memorize it. We have this variable and this variable. So basically we have two variables in our code which are changing. So we need to create a 2D dp that will look like this. Dp s dot length t dot length. Okay, and we need to initialize our dp with -1. Arrays dot fill our array with -1. and we can pass our dp here. So we have initialized our dp with the -1 value, and we can pass it into a function call. And we can check in our dp after checking the base conditions, means if these two indexes are valid, and we can check into our dp if we have already solved this problem, means if we have index is this, and index in s is this, and index in t is this, then for this particular indexes, if we have already solved our problem, means if we already have that answer in our dp, means if it's not -1, then we can return our dp. And if it is not present, then at the end we will calculate it and store it to use it in future. Okay, so we need to pass it into the this calls also. Let's run this. Okay, let's submit this. Okay, so this was the solution for it. So do I have previous submission for it? No, this was the first submission only. So that's how we can calculate it. So basically all dp questions till now have the same pattern. Mostly we are using this strategy, knapsack strategy, which is skipping and taking. Okay, then I think that's it. Thank you.